All right, hello. I've had a request to review this video from Sabine Hossenfelder. She's debunking flat Earth or discussing why we're wrong and why she's concerned. I've watched about the first half of it earlier today, but a lot of it I haven't actually watched yet. So I'll go ahead and watch it live right now and just do a live response.
I'm starting to get worried about flat earthers. I made a video about this a couple of years ago, and I thought that...
So real quick, if you haven't watched that previous video, it was laden with straw men of the flat Earth model. You can even see it in her image. She shows the flat Earth in space, which none, to my knowledge, I've never met a flat Earth that actually thinks that we exist on a disk in space and that we're in the stars. The concept is typically that the stars are actually above us, and what the nature of the celestial bodies and the stars are a mystery. We haven't actually gone up there to quantify what they are. And more importantly, when we're trying to do observations of the sky, and we're trying to use observations of the sky to make assertions about the ground beneath our feet and the motion of the ground beneath our feet, we actually it turns out we see these stars in apparent positions. And we know that going back as far as the 1800s with Airy's failure, when they put water into the telescope, they knew the exact correction angle they would have to impose for the telescope to if the Earth was in motion versus the sky, then they would have had to impose a correction angle due to the refraction rate of the water when Airy filled his telescope with water. And they didn't have to do that. The correction angle that they needed was like an order of magnitude lower and indicated that the Earth was stationary and that the sky was actually what's moving. So just a real quick response just to her initial video, because I did watch, I think, the whole thing at one point.
That it was a temporary curiosity, like some religious sects have a moment in the sun and then disappear. But the flat earther community seems to be growing. On the face of it, flat earth beliefs are completely bizarre. Most flat earthers think that the earth is a disk with the North Pole in the middle and the South Pole is a wall on the outside that keeps the water from escaping. They can't really agree on where the continent
keeps the water from escaping. Again, she's going back to her disk in space. A lot of flat earthers believe in biblical cosmology, which actually would indicate that we are within the waters. There's waters below us and waters above us, just like is in the Torah, just as in the biblical scriptures. He separated the waters from the waters. So there's nowhere for the water to run off or fall off to. Some people ask where the edge of the earth is. I would wager that probably no one has actually measured the face of the earth. You may call me crazy for that. I think things get a little bit difficult in Antarctica. I could be wrong. I can't verify. It's illegal for me to go and freely verify what's happening in Antarctica, right? I'd have to pay money and go on a guided trip to a specific place for a specific amount of time that I'd be legally allowed to go to Antarctica. But let's continue with Sabine.
are, or how many there are, or whether the South Pole maybe extends all the way to infinity. So it's a flat Earth multiverse theory, basically. Part of the reason people believe in this is just a lack of basic science education. Some of them think that if the Earth was a...
So, okay, like obviously most of us understand gravity pretty dang well, pardon my French. And that's actually how we got here, because we did our investigation. I've shown numerous times my massive sci-fi book collection, and it was hard sci-fi, not Star Wars, where they're just making up the Force to make things work, and they don't have to actually go into hard science for how they're doing their warp drives or whatever. I liked the good stuff. I liked Red Mars by Kim Stanley Robinson, the Red Mars trilogy, and a lot of Kim Stanley Robinson, because he actually tried to stick to, hard science within the conceptual framework of the Einsteinian cosmos. That's what I preferred to read. But there was, and he goes into the idea of space elevators and, fuel efficiency for getting to and fro a planet. And he even goes into, terraforming of Mars, terraforming of all the planets, life on spaceships. How you would impose a centrifugal gravity on the Ares in the Mars trilogy is the ship that they travel on, and he goes into the radiation. He goes into the centrifugal force that you would do to impose gravity so that people's bodies would stay better or whatever. But I'm starting to think these days diamagnetism would probably actually, or hypomagnetism would probably be the biggest problem. You leave the Earth's magnetic field. Once you leave the Earth's magnetic field, you have tons of health problems. But let's continue with Sabine's crap.
Globe, then water just run off on the South Pole.
This video, this guy's got literally covered in dirt. She's playing this guy like, oh, this is what we are. This must be what I look. I've dirt on all over my hands. I'm pouring water on a basketball. Okay.
Or pulled down by, I wonder what. They also misunderstand how perspective works, how trigonometry works, how cameras work, and on it goes. But it's not just a matter of misunderstanding.
So the ping pong ball thing, like, actually go do that for yourself. Go point a light at a ball and see if maybe if it doesn't actually make a perfect Terminator line like it would on a moon, on our moon. The crescent moon is not really so simple to explain, actually. So actually just, take a look at that objectively and use your brain with that. And there's a lot of different ways to explain the geometry of that's going on with the moon. If you could use a quadrupole with a dielectric and a magnetic with the sun and the moon moving through the quadrupoles, and like a phenomenon that would occur with that. That's not necessarily the theory that I subscribe to. Some people, there's a theory of the geometry of the black hole sun, which would be projected upwards from the center, going outwards. Everything, if everything's within a toroidal vortex, then I prefer not to try and speculate too much about the nature of the things in the sky. But the moon certainly is not easily explainable within their model or in our model, especially once you start looking at the quantification of the temperature readings of cold, quote unquote cold moonlight. I've only done some rudimentary tests of it myself, but I would recommend to maybe take that a little bit more seriously until you've done the test yourself. I was very skeptical of it until I did the test myself. Call me crazy. Let's move on.
If you believe that the Earth is flat, you also have to believe in a global conspiracy that's hiding the truth for no particular reason.
If I told you, let's say you're a glober, right, and you're sitting here watching this, if I tell you right now that the Earth is flat, you're going to argue with me. A lot of globers are going to argue with me and tell me that I'm wrong without even knowing why that I'm wrong. I've literally had it said to me, I don't know why you're wrong, but I know that you're wrong. So, yeah.
For starters, you must believe that most of physics is...
Most people are... My point with that was to say that most people are defending the globe without realizing what they're doing. And especially once you get people's egos and their pride wrapped up in what they're doing with these astronomers and these astronauts, the last thing that they're ever going to do is admit, that the Earth was flat and that they were wrong. People have their egos attached to their titles, and flat earther is besmirched amongst the cultures of the world. But let's move on.
Is wrong, and physicists are just making things up.
So first, what's funny with the Newtonian thing, right? That's really funny. Newton's wrong. Well, yeah, your model says Newton's wrong. You can't have a Newtonian framework and then also not measure a fringe shift during the Michelson-Morley experiment. Oh, whoops! I guess if we're gonna say that Newton's wrong, then okay, you can say that the Earth is relativistically in motion around the sun on a curvilinear path through a curvilinear geodesic. It's only measurably linear, but it appears to be curved, and that's why we can't measure an angular velocity. Oh, whoops! Well, Ruyang Wang came along in 2004 and measured linear velocity with the induction rate of light. So, yeah, sure, Newton was wrong in ways, for sure. I question the historicity of him himself, because he did a little bit too much, wrote a little bit too much for one person for it to really make a lot of logical sense to me. It would more be like a collection of works that were presented by a pseudo historical character. Maybe I'm wrong. Maybe Newton's a real person, but in any case, he definitely did a lot for mathematics. Thank you for, the contributions to calculus. Some people would argue he's the godfather of calculus, right? He obviously didn't discover gravity. Things fell before anyone, everyone knew things fell before he came along in 1666 and, observed an apple fall on his head or whatever. But let's move on.
All part of a big conspiracy. Geophysicists, they're also in on it.
Indeed. Indeed. Well, they're not in on it. Actually, they have their egos wrapped up in it. You can't become a geologist unless you give in to the paradigm. And I just did a presentation about that on Aether Cosmology. Go check out my geomagnetism presentation. I went very deep on the geodynamo, and I went very deep on the core of the Earth and the layers, the geological layers of the Earth that they claim and you go look at when we actually started drilling down into the crust, when they went 8 miles down, when they went, or when they went 7 miles down, when they went 5 miles down, and they ran into like 80 degrees, they were expecting 100 degrees Celsius at 7 miles down into the crust. When they did the super deep Kola borehole in Russia, they were expecting 100 degrees Celsius. Guess what they found? They found 180 degrees Celsius. The ground, the earth they were digging through wouldn't even stay solid anymore. Everything was plastic, they said, and there was the pressures were insanely like way higher, like almost twice as high as what they expected. The temperatures were almost twice as high as what they expected. Then you go to Oklahoma when they dug down, when they drilled down about what was it? I think they went like 4 miles or something like that. It was what was it like? It was 8 kilometers, so yeah, well, like three or 4 miles, and they ran into molten sulfur, which they weren't expecting to find because they weren't expecting, again, the temperatures and the pressure to be so great. So yeah, now geophysicists aren't lying, seismologists aren't lying. They're doing what they need to do to move forward in their career field, right? And just on a quick note, go find yourself a seismology textbook, an introduction to seismology textbook, and tell me what the first few chapters or the first unit are all about. Guess what it is? It's astronomy. They spend the whole first portion of the book talking about how everything in the sky is a sphere, so the Earth must also be a sphere. So they're not in on it. They're just beholden to the same institutional knowledge that we are all raised on. And most of us flat earthers are not the guy covered in dirt that she's trying to say don't understand how gravity works earlier. What's actually going on is that, you know, that's what the only, think about it. She could have brought an actual intelligent flat earther on. She could have talked to Austin Whitsitt. She could have talked to me or Alan or Shane or Jaron, or there's a million people she could have had on to talk about it. She could actually try and represent her point of view accurately, but obviously she's not going to do that. Why do you think that is? Continue.
Astrophysicists are liars. Everyone who's ever been involved in launching a rocket into space.
Real quick on the note about the astrophysicists all being liars. Well, first of all, if you haven't watched the Apollo 11, when Neil and Buzz and the crew are sitting at the podium, they're sitting at the table after they just got back from the moon, like one of mankind's greatest accomplishments ever, and they all have these I can't. They have frowns, pure frowns. They look like people that are realizing they're going to have to lie for the rest of their lives. They don't look like people that just accomplished something great. So some of the ones that happen to also be, 30, top degree Freemasons or whatever. By the way, did you know they brought a Freemason flag up to the moon? Isn't that weird? According to, their story, there was a Freemason flag on the moon. But I do think that some of them are in on it. Yes. And that's actually probably what happened with Gus Grissom, right? He was probably in on it, and then he put the lemon outside of the shuttle that he went up on, and he died. But most of them are not in on it. And actually, you go back and look. So there's two things that were very odd in my childhood that I think back to now. I think about the Disney, what was it? The Disney Kids Club or whatever it was, Disney All-Stars, and then there was Space Camp. What were these? What were these things? Why were they bringing kids into Disney and Space Camp? Well, because what they're doing, in my opinion, most likely, is they were looking for which kids had the proper psychological, the proper psyche that they could be manipulated into, being an astronomer, being a astrophysicist. They don't. Oh, is this person? How much do they care about truth versus, maybe the better way to put this is how quickly do they latch to institutional knowledge, and how beholden to that institutional knowledge will they remain? Will they challenge their views? And I don't think you're going to get a kid that's going to go through Space Camp and then going to end up in NASA if he was a critical thinker, most likely. Not call me conspiratorial. Okay, fine, whatever. Call me a critical thinker. Let's move on.
Space or putting a satellite into orbit is part of that conspiracy too. Moon landings didn't happen. The ISS...
I could go on about satellites for a while. GPS itself, the documentation of how GPS works, the classical mechanics of how GPS works actually falsify special relativity. You might not know what that really means if you haven't looked into this, like a lot of people haven't, but if special relativity is not right, then the Earth is measurably stationary. Ha! GPS, the reason that it debunks special relativity is because the speed of the receiving craft, the receiving GPS craft, that velocity is directly related to, so they have to account for that. It's called a Sagnac correct, or actually it's inherent, well, inherent within the range measurement of GPS, range measurement equations that they use, and they use the speed of light proportional to the receiving craft to determine how far away those crafts are from each other. And if that proportion, if that craft moves away and the speed of light changes with that craft, with that inertial, with that frame, with that reference frame, then that means that the speed of light wasn't constant. And if the speed of light isn't constant, then that means in 1887, when they went to go do the Michelson-Morley experiment and measure the orbital speed of the Earth using an orthogonal interferometer setup, they should have measured it, and they didn't. So let's move on.
Not in orbit. Every single photo that's ever been taken of Earth.
Just really quick. So satellites, right? They could be balloons. It could be. I do think a lot of communication is done via balloons, and I think that balloons are just a cheap and efficient way to do those sorts of things. Even if you were a globe believer, NASA is objectively the largest purchaser of helium on Earth. And so even if you believe in the globe, you have to acknowledge the fact that NASA has a lot of investment into helium and weather balloons, or satelloons. And that's okay if you're a glober. You should acknowledge the truth. But I think when you start looking at these patterns of what's going on up there, there's a lot that I don't know about what's happening in the sky, and that you certainly don't know. And most likely what they tell us with satellites is just the tip of the iceberg with the technology that they have, with what they can do with the sky, with quantum locking, or with riding the ether wind. And that's measurable, by the way, because Dayton Miller, back in the early 1900s, he took the Michelson-Morley experiment that I mentioned just a few minutes ago. He took that same interferometer setup and went up and down with it. He went up to the Mount Wilson Observatory in California and went higher up in elevation. And then he checked in Cleveland, Ohio earlier. And when you compared the velocity of the ether wind in those two places, there was actually greater at altitude in Mount Wilson. So the ether wind, which is the preferred directionality, simply put, the preferred direction, the speed at which the light travels west to east, east to west, is faster west than it is west east. It's actually slower west to east, and there's no difference north and south, only going those two directions back and forth. I would say because of an ether vortex that we exist within. Now, the important thing is that when you go up in altitude, that effect grows. Oh, and another really important note, that's just a little side note here, that effect, the speed of that effect, that preferred directionality, the speed of light, the fact that you get a fringe shift when you're measuring with an interferometer, it actually correlates with the equinoxes. So the motion of the sky, the sun in the sky, is having an effect on the fringe shift reading that an interferometer is taking, an orthogonal interferometer is being picked up on the east to west directionality. And that's been corroborated by a Ukrainian, Yuri Galev, back in the 2004, 2006, 2007. He corroborated, 2001, 2003. He corroborated specifically the altitude thing. He corroborated a bunch more of Dayton Miller's work through other means via, he tested some of Dayton Miller's claims about metal shielding and dielectric insulators around interferometry, but that's I'm already way off in the weeds. So let's get back to Sabine's crazy video.
From space, fake. Sounds pretty crazy, doesn't it? But then lots of people also believe that an omniscient being.
Now, real quick on the thing about space being fake, let's just think we've seen Arctic lemurs in the space footage on Mars. The pictures that the Mars rover took had an Arctic lemur native to Greenland, which is also where they do their Mars training. Why was there a rock that looked exactly like an Arctic lemur? You can look at ISS footage where there's a moth flying around. There's footage with bugs, insects. You can go and find pictures of bubbles going up in the middle of space. All sorts of issues like that. Just go watch the Apollo 17 liftoff from the moon. When they say, "We're on our way, Houston," and this little thing shoots up with this rainbow stuff flying out the sides, and the camera pans up. They sent an 8-second signal, 8-second advance signal, an 8-second advance radio signal to a little camera on the moon that panned up. They did that just to get a pan up of the Apollo 17 lunar lander popping off the moon. Really think, why were there so much theatrics involved? And then just go watch it and think to yourself that that little lunar lander, that little rinky-dink thing that they're in that boop pops off the moon, that thing's about to go 2,200 or 2,200 miles back to Earth through the Van Allen radiation belt. They've got enough food. They've got enough water. They're going to get rid of their excrement. No problem. Let's continue. Oh, and so now she's going to gaslight us. She's going to compare it to religion, which is just hilarious, right? Because there's nothing more religious than thinking that the ground beneath your feet is curving down and away from you in all directions and it is in vast motion without any measurable proof.
Being keeps track of who they have sex with. A recent representative poll in North America found that 5% think the Earth is flat and another 6% aren't quite sure. I'm not quite sure how many people lie in these polls, but there's no doubt that interest in flat Earth ideas has spiked in the past decade, as you can see in the Google search trends. In 2009, the International Flat Earth Society set up a website. In 2013, part of its members set up a wiki and discussion forum. Around 2015, the topic started to appear on YouTube and spread from here. In 2017, the first Flat Earth conference took place, which attracted a lot of media attention. YouTube made big changes to its recommendation algorithm and interest tapered somewhat off after that. But rather than just fading away, in recent years, interest in Flat Earth has been on the rise again.
That's despite the insane censorship. And it's hilarious because honestly, nothing made it seem more real to me than when I started looking into it a year and a half ago and I saw how censored it was. Like nothing made me think, I should probably look into this more than seeing how censored it was and seeing the stupid little notices all over the place from the, from the UN or whatever. Or the, WF, I don't know, who knows who that really comes down from, but I know it's like a wiki post or whatever, but yeah, that's despite the censorship, it's growing. That's us learning to adapt and deal with this, us putting out videos and just putting out more and more content despite everything, right? And then, thanks a lot to people like Austin Whitsitt getting on InfoWars. I think that's helping us gain some traction right now. But let's
It's probably to no small part because of TikTok, which has now become a haven for flat earthers. Scientists don't take flat earthers seriously, and I can see where they're coming from, but I think it's a mistake.
So there's a weird assertion,
to me,
right?
flat earthers...
You just said, scientists don't take flat earthers seriously. Okay, like, are you going to quantify that by any means? It's a meaningless, empty, just asinine, totally asinine statement. Flat Earth or scientists don't take flat earthers seriously. How many scientists are flat earthers? Quite a few.
Are the first symptom of a much bigger problem.
Most of the scientists, most of the actual well-versed physicists, they don't want to argue against flat Earth. And maybe they're globers, maybe they're fully indoctrinated. Most of them probably are. But they're at least wise and smart enough to know how insane their theories are and how their theories are literally riddled with paradoxes. I mean, there's a list of paradoxes I could pull up. If you absorb the heliocentric model with general relativity and special relativity and their understanding of quantum mechanics, all is one thing, right? This all goes together. If you absorb all of that, then it's tons of literal paradoxes. Have fun with your cognitus. It's real, right? It's reality, but it's causing cognitive dissonance. Guess you just gotta exist with cognitive dissonance. No, it's not. That's not because I'm too stupid to understand it. Because they're literally paradoxes. Einstein-Rosen paradox, the Podolsky or Einstein-Rosen-Podolsky paradox, the twin paradox, relative simultaneity. Which, by the way, Sabine, you actually did a video, what was it, like a year ago, where you totally misrepresented special relativity. But, everyone likes, a lot of these physicists, they like to invoke their own explanations for special and general relativity. Turns out it's not actually so easy to do. They typically always do something wrong. You know, like in a really simple way, like a really simple mistake that a lot of people will make when they try to explain just a little local interferometer that happens, right? Like what I mentioned earlier, Ruyong Wong back in 2004 with a linear interferometer setup where he had a linear portion of the wave core fiber that moved in a linear vector, and that was proportionally measured in the people will try to explain that by invoking absolute space. They'll say, oh, well, you take this point in space, and then, you know, it's now at this point in space, and so that moved the whole light wave. Relative to the movement of that relative to the light wave caused the light wave to move, but that didn't change the speed of light. But more importantly, go to page 1 of 1905, Albert Einstein's on the electrodynamics of moving bodies, and go read what he said right after he calls the ether superfluous. Go read what he said right after that. He says that we can't invoke velocity vectors to points in free space. Because guess what that's doing? That's invoking a background medium. You're invoking absolute space. The whole point of special relativity is to get rid of absolute space. So good luck explaining what Georges Sagnac did in 1912, or what Ruyong Wong did in 2004, or explaining GPS. Huh. All right, sorry. I'm sorry to get emotional, but, you know, someone asked me to make this response video, and I knew I was going to... A little verbose, pardon.
They show us what happens when people realize they can't understand modern science, don't trust scientists, and therefore...
Wait, which one is it? Is it can't understand modern science, or is it didn't trust scientists? You just said two things that are very different from each other, Miss Sabine. Let's listen to that again.
That's a much bigger problem. They show us what happens when people realize they can't understand modern science, don't trust scientists, and therefore throw out.
Which one is it? Can we not understand science, or do we not trust modern scientists? What is science to you, Sabine? Is it what scientists say, or is it like a scientific method that you're trying to invoke here? Because it's not making, like, what you just said was two statements that weren't really coherent with each other. They're kind of almost incongruent with each other, because they're basically just two totally different ad hoc statements that are just trying to gaslight flat earthers, or gaslight the person on the fence into being afraid of looking further into the flat earth. Go look at some laser tests. I can point you to a link. Maybe I'll drop it in the description of this video. Go take a look. 14 out of 14 laser tests all measured the Earth to be flat. You go look at it from the side, see the side of the laser beam. It looks perfectly horizontal. Guess what the Glober's going to tell you? They're going to tell you, oh, it curved magically around the Earth. We know that. That's how refraction works. No, refraction does bend light downwards. Does it bend light downwards perfectly around a sphere 14 miles, 30 miles every single frickin' time to look perfectly straight? Or, okay, not every single time. Let's be clear. Not every single time. Because refraction is a thing. But 14 out of 14 laser tests measured perfectly flat, and I got Globers literally telling me I don't understand refraction, and that 14 out of 14 laser tests just curved, even though we couldn't tell. And some of them that are, you know, yeah. I'll drop the laser tests. Go look at observations. There's observations that have been made way too far. They don't just see Chicago across Lake Michigan, which is way, like, it's supposed to be behind hundreds of feet of Earth curvature, but now you can see Milwaukee across Lake Michigan. From Muskegon. You go across Lake Michigan, it's supposed to be hundreds and hundreds of feet of Earth curvature, and the buildings in Milwaukee are not skyscrapers like they are in Chicago. They're supposed to be hidden behind Earth curvature. There's a radius value in the globe model. And that's why they say that the horizon is a physical thing. It's a physical obstruction. Things are supposed to be able to be hidden behind the horizon at specific rates, specific distances. But we have all these observations. I'll drop a link to the Flat Earth Wiki, one of the Flat Earth Wikis. There's more than one of them, because there's a bunch of people that have all this information that's censored, and they want to get it properly indexed. So we've got multiple wikis out there, but we can't even all work together because of all the censorship that Sabine's in favor of.
Even the most basic scientific knowledge on the rationale of
Sorry, I touched on the motion thing with the interferometry, and I touched on the laser test. I touched on the observations at distances that are too far. I didn't talk about optics and how optics literally impose a curvature. And when you look into the Rayleigh value, the way that angular compression works, the way that optical compression works, the angular resolution works, it turns out you can literally end up drawing up a globe. It turns out our sphere of vision matches what they call the radius value of the Earth. That's due to angular compression with the horizon specifically. Our field of view only goes so far out for the average observer height of around, say, 5-6 feet or so.
Of skepticism, flat.
And that you got to take into account the aperture of your pupil, right? And any optics that you take into it that you bring into this aperture is relevant with the angular compression, or with the Rayleigh criterion essentially. And yeah, let's continue with Sabine.
Earthers are somewhat extreme and that they're actually throwing out evidence that they could test themselves if they weren't so bad at science. But the underlying problem is much...
Is she going to mention what those are? She just mentioned how we could test this. Was she going to mention how?
Modern science don't trust scientists and therefore throw out even the most basic scientific knowledge on the rationale of skepticism. Flat earthers are somewhat extreme and that they're actually...
The lack of specificity is just disgusting, honestly. It's gross. Like, what did she even... She didn't say anything just now. It was like the most broad, sweeping statement without a degree of like she doesn't have to explain anything. Like, apparently she doesn't have to explain anything. She can just say that she can just claim that we don't trust science and that we don't do scientific experimentation. She's not going to tell us which scientific maybe she will. Let's keep listening.
Throwing out evidence that they could test themselves if they weren't so bad at science. But the underlying problem is much deeper, because in most of modern science, the average person can't test evidence for themselves. This is why I think it makes sense to can't test evidence for themselves.
No.
This is why I think the average person is much deeper, because they weren't so bad at science. But the underlying problem is much deeper.
All right, hold on. Look, Shane's model is not perfect. Go to planar.earth. It's not perfect because the things in the sky are in apparent positions, and that's just the nature of something. Go have a bunch of people stand around a swimming pool, and put a quarter in the bottom of the swimming pool, an empty swimming pool, empty it. You got people standing around it, put a quarter in the bottom, and say, everyone point at the quarter. And then fill the pool up with water. Tell everyone, point at the quarter. All of a sudden, it's going to change a little bit for everybody, and you're not going to have a perfectly congruent point anymore. And that's why my point with saying that is that when you don't even know the medium of the sky, what you're looking through, how much magnification is occurring, how much refraction is occurring, you don't know the distances, you don't know the sizes. All we really know are angular sizes. You could try and go off NASA's data. If you really want to trust the serpent that repeatedly lies to you, go ahead. So let's just take a quick look. Go to planar.earth and look at Shane's model, Shane's flat Earth model. You can see how the dome of vision works, and this is what the days and nights actually look like. So this is the time of the day, and so you see here, right? The sun just does that, and then as you change the time of the year, the effect of the sun as it moves in and out, see the way it's moving in and out here? What you can see is how you get the 24-hour day, and this is called the coffee cup caustic effect right here. How you get the 24-hour sunlight in Antarctica. Now this is another tangent, but a video was released of 24-hour sun in Antarctica, and they showed it was a time lapse of the sun going all the way around, doing a full 24-hour loop, which, to these people, they think that the intangibles in the sky are what we should be using to make assertions about the tangible ground beneath our feet. But regardless, the video ended up, like, literally, if you look close enough, you can see there's a lens flare that comes in at the exact same moment, at the exact same second, the exact same time, with the exact same rays of sunlight coming around, which means that the video itself was manipulated and what's the word I want? It was manipulated. They duplicated that footage of the sun, of that part of the sun. So that was one. I believe there's another one that was a fake. And then now, ever since then, ever since we caught them on that one, there's been multiple others that have come out, and I'll admit, they look intriguing, some of them. But first of all, like I said, this is an intangible in the sky, so it's not where I'm personally looking to find out what's going on tangibly with the ground beneath my feet in the first place. But it would be quite intriguing if there was actually we could actually see the sun for 24 hours in Antarctica. But once it's been faked once, it's hard to take the new ones seriously. Especially when you can get to the point now where it's hard to tell what's even fake or real. You go, here's an example, go pop Netflix on these days, change the English from English to French. I heard this. I don't actually watch Netflix, but if you change the language on newer Netflix series, apparently these days, change it from English to French, and the mouths will move. Everything will change, but you won't. It's not a dub anymore. Everything is just AI generated. The face, the mouth, everything. So, if you think that they don't have a higher degree of graphics abilities at the upper echelons of government institutions, you're not being real with yourself. But let's move on. So this is what the sunlight would actually look like, right? She's got this insane leapfrog thing going on.
So bad at science. But the underlying problem is much deeper. Because in most of modern science, the average person can't test evidence for themselves. This is why I think it makes sense to identify the origin of this problem. And some scientists have actually studied this. They found that the scientific literacy of flat earthers tends to be well below population average. And at the same time, they're much more confident of their scientific knowledge than the average person. On top of this, we then get echo chambers in social media that reinforce their misjudgment. The trouble is that these two issues, lack of knowledge...
If you're a flat earther, or you were on the fence, and you watched this, and you got brought back the other way, maybe you weren't a critical enough thinker in the first place.
And an inability to recognize this lack of knowledge are bound to become increasingly widespread, simply because, unfortunately, scientific knowledge isn't heritable. We're born without knowing anything of modern science. We have to learn everything. And the more sophisticated science becomes, the more learning that requires. Sometime in the middle of the 20th century or so, we reached a point where modern science just stopped being comprehensible to anyone without a special degree, and this is still the case.
Okay, real quick. If you have to have a special degree, and it's too complicated these days, does the person with the special degree in quantum mechanics have any idea what's going on with the gravitational lensing effects that are being studied by the astronomer at NASA down the street? And does the guy a few cubicles over at NASA that's studying gravitational redshift, does he have any knowledge of what those other two dudes are doing? Does he even think about the implications of what he does, or does he just write it down in a book and then give it off to someone else to analyze? And more importantly, if he was a space camp kid and he got brought in because of his love for space and his love for NASA, his undying loyalty to the NASA cult or whatever. Pardon, I'm sorry if that's insulting to you, but if he got brought in for that reason, then he's never going to care. He's never going to look for some profound way that they're wrong, that the institution that he's built his whole life around, he's probably not going to try and call him out. And I don't mean that in a way where he's trying to protect his own interests or whatever, like he knows. No, this is a spiritual psychological thing where these people, they have bought in and attached their egos to a deception unknowingly. Just like we all did, just like I did.
Really understand how CRISPR works. I've no idea what Teichmuller theory is. I don't know how phones work, and I yet have to figure out how to properly fertilize our lawn.
But that doesn't mean that those people can come and make assertions to you about those things that you have to take to be true. They still have to be able to prove their assertions. They still have to use scientific experimentation to test their hypotheses. Sabine, you're missing a lot here. This is important logic stuff. And you're supposed to be one of the countercultural ones. But you're not a critical thinker, it seems like. Please, Sabine, I hope this gets a little bit... It's not. I hope it gets better, but it's not going to.
There's just too much knowledge in the world to learn it all, and unfortunately, no one has
the Earth
yet
must be a
developed.
globe. There's just too much knowledge in the world for us all to, so it must be a spinning space ball. Must be an illusion that even though we can't measure any motion, even though we can't feel any motion, even though we can't measure any curvature, even though we can't see any curvature that exceeds, or that we can't bring back into view, right? Like, oh, the boat goes over the horizon. Oh, well, pull your telescope up and zoom in. Grab your lens and zoom in. Go 200 millimeters and bring the boat back into view. Oh, ooh, whoops. Oh, then we should be able to see all the way around the world, right? Because you should be able to see forever. Well, no, not really. Because it turns out there's an attenuation rate of light. There's an inverse square law of light. Light does not just go forever. They had to make that up so they can make up some of their crap about the stars. Light doesn't go forever. They can say that because they say it's a vacuum. So there's no attenuation. Just this like magical, just goes forever. But when you look, but guess what? When you actually start taking into account the way the optics should really work, and you put it on a flat Earth, what you should see at the horizon is a fuzzy gradient, where the sky appears to meet the ground, and no matter what level of optics you get as you zoom in, the attenuation from the atmos, especially near the ground, is too great. And it's going to start to move around. It's going to be blurry. It's going to be fuzzy. Get a fuzzy gradient exactly as observed, which is exactly what you would expect on a planar Earth. Now, on a globe, you should expect a physical obstruction curving downwards that you can measure at a particular radius value without having to throw out the measurements that disagree with you. Go look into geodetic survey. That's a fun one. Turns out it's all reifications. You have to deflect to your vertical, so that everything is mapped to the sky, to the WGS 84 or one of their ellipsoids, and you can throw out your errors that don't match it. You do an error rated you do error weighted models to throw out the stuff you don't want, and then you invoke a level of refraction that gets you part of the way there, and then you're usually still 10-20% of the way out, but you just call it good enough. And yeah. Let's hear what else you got, Sabine.
Developed a pill for quantum mechanics. But you don't actually need to learn any physics to see that the Earth isn't flat. Even leaving aside that it requires you to believe in this huge conspiracy, flat Earth ideas have a much bigger problem. Is that you can't do anything with them. You can't use them to do as much as predict sunset and sunrise, let alone tides.
Well, I just showed you Shane's flat Earth model. Like, important thing to note here. We're not making any assertions. This model is not making assertions about the dynamics of the sky, which accounts for real masses and real forces and real masses, right? That's not what we're doing here. All we're doing is mapping the kinematics of the sky, which is just the observed motions of the sky. We're mapping that to this AE projection. And this isn't perfect, but it's just showing how it would work. Now, it's not easy for us to do this perfectly. Because first of all, this is just a JavaScript coded map, so that's not a very easy thing to make perfect. But it turns out you go back to the 1800s, the magnetic field and the magnetic declination that's prescribed to all navigation on the Earth to do your navigations with a compass, you'd have to you correct for magnetic declination. Well, that all goes back to the Royal Society in the 1800s. Same thing with the longitude and latitude lines. And as you go outwards, like this whole thing is all mapped to the sky, and it's all based around a very particular set of coordinates that legally you can't even really change. Like what's his name? Gleason, the Gleason map, he had to include the longitude and latitude lines on that legally, is my understanding. I should probably double check that information. But my point is, give me 200 years, a decree from the king, the Royal Society, on a fleet of ships to send around the world. I'll give you an accurate map. Give me all that stuff. A couple hundred years, whatever. I'll give you an accurate flat Earth map, probably, maybe. I don't know. But I just tell you what, man, like there's proportional issues with the globe that are hidden within, countries, areas that are not traversed. Yeah. There's incongruencies all over the place, especially when you start looking into, like I said, the magnetic declination. Let's go back to Sabine.
or solar eclipses or the paths of planets.
Eclipses are just based on eclipses are explicitly based on geocentric predictions. NASA gets all of their data from Fred. Shane St. Pierre did fantastic work on this. You can check that out on Aether Cosmology or Space Audits. Go check out Shane's work on an ADL, Anti-Disinfo League, the good one, quote unquote, in parentheses. Go check out Shane's work. Shane did great work on the eclipses, and what he found, he dug into it quite deeply. Everything is just based on math. It's all based on the Saros cycles, and it uses a geocentric framework. There's nothing heliocentric in the math of the eclipse predictions. It's just a sine function or cosine function. So
planets. You can't calculate airplane routes or understand satellite navigation. Even
that's a very deep topic. Or it's another rabbit hole to get into, but you go look at Aether Cosmology, check out Model Builder's video about GPS and what he was showing us with the GPS data that he had. Basically, when you have a global coordinate system that all travel uses, even airplanes, then you don't actually know the absolute distances that you're traveling, especially once you start going through wind currents in the south, right? And you start going over large distances of ocean water. A lot of people don't think about this, I guess, but you can't measure your absolute velocity. You can't measure the velocity of an airplane without measuring it relative to something. So if you're in an airstream and you're measuring your velocity relative to that airstream, you don't actually know your absolute velocity. You can only know that absolute velocity, quote unquote. They would tell you the only way to know that is through GPS. So you can't use plane travel, can't use GPS, can't use the global coordinate system to prove the global coordinate system. It's called reification. There's nothing logical about that. There's no proof there. And if you go and look at some of the flights that they say are a problem on the FE map, on the azimuthal equidistant map, you'll actually find that most of those flights go way faster one way than the other, and that's due to jet streams. So maybe we'll go on to that, in more detail another time. But this is not a simple globe proof, especially when you're not even getting into the proper details, right? Like if you were going to actually try and properly argue this to a flat earther, you'd have to understand what I just laid out, which she's not. Maybe she doesn't understand it, or maybe it will never even take the time to properly humor it. She'll make videos addressing it without properly knowing what our arguments are.
Even if you know nothing about how scientists do calculate these things.
This is hilarious too. Like, look at how many of these are all in the north, in the circle, right? If this was a great circle map, all of the like a huge portion of the transportation here is all right here. There's not even that much of it that is in the south. And what do you know? A lot of these are doing these a downward looping motion to go catch jet streams. But continue.
It isn't hard to convince yourself that someone somehow did manage to actually calculate when the sun arises and when solar eclipses.
Again, this is just kinematics in the sky. No one's going into space to look at where a ball is to try and determine when day and night's going to happen. This is all just cyclical motions. This is just the Earth is just a polyrhythmic machine. Where these beats come in and out of sync with each other. All that's going on, and you're just looking at it on a map. Nothing to do with space. Nothing to do with proving the Earth not being a ball. Especially once you wrap your head around the celestial sphere and the way that you perceive outwardly in a circle around you. You have a dome of vision. So when you look up at the sky, you see in a dome up and down and back around you. And what that ends up creating when you map the sky out, you end up creating a celestial sphere. And so, sky observations are not something that flat earthers have a problem with. It's just sky observations. Just take those things and put them, they're already in apparent positions, even in the globe model. They are not in exact positions. Everything is apparent. Go back to what I just said earlier about Aries' failure with the starlight. Everything is in apparent positions. So it works just as fine on a flat Earth. And then when you start looking into the scaling, it actually makes sense that you would have, as you come down and you start moving from looking up at the sky, the plane above you, and your angle starts to change going to that plane above you, you would get, which is the measurable logarithmic effect of peaking down into that exponential point at which those train tracks converge, right? Think of the train tracks converging, flip that on its side, and what happens when those train tracks converge on a above and below you level? Well, you're on the lower train track.
Will occur, and those were not the people who believe that the Earth is flat. Why do flat earthers not realize this? I suspect what's going on is that they don't have the faintest clue how modern science works. They might actually believe that...
Be your own judge. Does it sound like I don't have the faintest clue about how modern science works? Does it sound like I don't understand Newtonian dynamics and the way that it hilariously is really Newtonian dynamics as applied to the sky work off of a scaling law, like the periodicity of the orbits is directly proportional to the masses end up canceling out because the periodicity is proportional to the radius of the orbit. Essentially, what Newton did was a trick to take the kinematics that Kepler observed and try and apply a dynamic explanation for what's happening without actually having to apply any real accounting for forces and masses. And the thing about the forces is a whole other thing, because that's when you start getting into the argument about how orbits should really work and what they say works and the way that they should actually work. It's not a simple thing. Like, think about it. Can you really argue orbital mechanics to me? Really? Like, think about it. The trajectory of a ball falling towards the Earth and never actually collapsing in on the Earth. It's kinematics. It's based on a kinematic motion, and where you take the gravity out. Now, the gravity will work on one body, but you're taking a leap of faith to even make that math work in the first place. That's the point I'm trying to make there. You've got Newtonian dynamics, which are not unproven, unfalsifiable and unproven. But then even that, you have to go into the next step with special relativity, as I laid out earlier, because otherwise you have a problem with 1887 and with the Michelson-Morley experiment. You should be able to measure the orbital velocity of the Earth, and you can't. But
that drawing a rotating blob on a disk in Blender is the state of the art in physics. So what are we to do? There'll always be people who distrust scientists, and that might not even be a bad thing. But I think it's a mistake. It might not be a bad thing.
It might not be a bad thing for people to distrust scientists. It might not be a bad... So does that mean we should just never test their claims? Huh. Sabine, have you ever taken a course in logic or maybe just read up on logic? You don't have to take a course, just read, but just look into or just use your brain, think about logic and about the way that you test things. It's hilarious too. You use the term, you throw that term science around like like it means something to you, but... Oof.
To ignore flat earthers. And I do have some sympathy for them. I really do. They're trying to figure out how nature works. And that's a good thing. Yes. We should just encourage them to get better at it. And then maybe one day they'll figure out that it's actually much easier to explain their observations if they stop believing that the Earth is flat. Another reason I think we should take flat earthers seriously.
That little spot, that to me, that feels like the that's the psychological appeal to the flat earther, right? Like, come back, stop, you're not supposed to believe it. Do not believe that the Earth is flat. They do the little jump cut, and they're like, this is serious, don't believe it, because apparently it would be bad for us all if people felt it. I'm going to digress again one more time because really, this is important to me. What does my cosmological view have to do with you? If I decided that living on a flat and stationary Earth made me feel more grounded and made me feel like I had less cognitive dissonance, then what do you care? There's zero pertinence of your globe in my day-to-day life. Zero pertinence whatsoever. And if it feels psychologically better for me to be on a flat stationary Earth, then you're not in any position to tell me what I have to believe. The origin of everything, where everything comes from, cosmology, the origin of everything, from the quantum scale to the quantum scale to the cosmological scale, everything from the top to bottom, from bottom to top. You're going to tell me how to think about that, what I'm allowed to believe about that? That's the deepest level of philosophy. That's the bedrock of my orientation in the world that I live in. You're not going to tell me what I'm allowed to believe and not allowed to believe with that. Especially, personally, when I'm testing these things and I'm testing my own knowledge. As per scriptures, by the way, if you happen to be a biblical person, you're supposed to test all things and hold fast to that which is true and good. So are you doing that? Are you really testing it? Did you go actually talk to that flat earther and ask what their point of view was? The way that they're looking at this? You don't have to be a scriptural person to understand, the way that Inquisition works, right? The way that or inquiry works. Excuse me, not Inquisition. Inquiry. The way that inquiry works. Like, when I first started getting into this, like researching this, it was like the one thing I kept thinking was, like, this is such a good thing. Like, I'm learning so much, even before I was a flat earther. Like, there's these, I never thought about this stuff. I never thought about the orbital speed, the rotational speed, the radius value, like, I did think about the twin paradoxes. I read all that stupid, crap about all that sci-fi crap. This is getting really long. I'm going on an hour. I'm sorry if you expected this to be short and concise, and it's not short and concise. But there was a lot to say about this, I guess, brewing here. So someone asked me to make this. Here we go.
Figure out that it's actually much easier to explain their observations if they stop believing that the Earth is flat. Another reason I think we should take flat earthers seriously is that a lack of science education is more of a societal failure than a personal one. Luckily, there's an easy way to grow your scientific background knowledge, which is on brilliant.org. I really like Brilliant's courses because they get to the point very quickly and help me
Tell you what, you go and take a course at a university, college, or a university or a college, a public institution, any of these institutions, one of the Jesuit institutions. They're not going to tell you about what Ruyang Wang did in 2004. And you might want to ask why they're not going to tell you that. They're not going to tell you about the Neo-Tychonian system of the planetary motions, and that you could have a kinematic equivalence between geocentrism and heliocentrism. AKA, the Earth can literally not be in motion, and even per Einstein, Mr. Albert Einstein, that everyone loves, even per him, you would never know the difference, because there's a kinematic and dynamic equivalence in their model, thanks to Mach. This is just her talking about her ad. So
computer science or maths. Whether that's special relativity or quantum computing, Brilliant has you covered. If you use our link brilliant.org/Sabine, you get to try out everything on Brilliant for 30 days for free, and you'll get 20% off the annual premium subscription. So go and check this out. Thanks for watching.
I'm talking over Sabine. This is done. I'm done pretty much. But, like, you want to make me a flat earther, like, please. Tell me, Sabine. Leave me a comment, Sabine. Tell me what I'm missing here. That was the most substanceless video I've seen in a while. That's what we always get. And, like, Sabine does some videos that actually have some substance, but there's a thing with flat earth, right? Like, you'll talk to the most logical person, the most, like, honest, logical person that you think you know, right? And you're like, oh, this will be a good conversation. This person knows how to be a critical thinker, apply logic, have a reasonable conversation. You go and talk to that person, but then it's like with flat earth, it's like they throw logic out and they start glitching. There's a glitch that occurs, and it's like, it's a ball, like I can't become a flat earther. That'd be too big of an ego hit for me. That's what a lot of people seem to run up against. I'm rambling. But I hope this addressed her points. Take any point. Take care, everybody.